Hi, this is Sir Aris again. For the next part, let us discuss on sections 1.7, 1.8, and 1.9. Um, if you have an alternating series, it converges if the absolute value of the terms decreases steadily to zero. That is, if uh, one term, an plus 1, is less than or equal to an, and the limit as n approaches infinity is 0. Example, consider the harmonic series with alternating signs. You have 1 minus 1 half plus 1/3 minus 1/4 plus 1/5 and so on. We know that 1 over n plus 1 is less than 1 over n. And the limit also, as n approaches infinity, is 0. So the series converges. The absolute values of the terms in this series give us the harmonic series, which we know is divergent. So we say that the series is not absolutely convergent. For a series like in the previous example, which converges but does not converge absolutely, it is called conditionally convergent. In this case, we must be careful in handling this kind of series. One reason is that it is possible to rearrange the series and the terms in the series of a conditionally convergent series and make the sum any number that you want. For example, in that alternating harmonic series, if we want to make the sum equal to 1.5, we can do that by simply rearranging the series so that we add few positive terms to get a sum of a little bit over 1.5, then add a negative term, and then add terms again so that it goes just over 1.5, and then add another negative term, and then go on. For example, here we demonstrate it for the alternating harmonic series. We first add 1 plus 1/3 plus 1/2, that gives you 1.533. Minus 1/2, or minus 0.5, gives you back 1.0333. Now we add few more terms, 1 over 7, 1 over 9, 1 over 11, 1 over 13, 1 over 15, minus 1 over 4. That would be 1.5218 for the positive terms, including 1.0333, minus for 1/4, that's 0.25. Continue the process. You have 1.2718 plus these positive terms. That gives you 1.5144 minus 1 over 6. That would be 1.3477. And then add terms again for it to reach just above 1.5 minus another term, and then continue the process. So as we continue, we will get partial sums just a little more or a little less than 1.5. This illustrates why we must not rearrange the terms of a conditionally convergent series. Finally, here are useful facts about series. The convergence or divergence is not affected by multiplying every term of the series by the same constant, non-zero constant. So neither it is affected by changing a finite number of terms, for example, omitting the first few terms. Two convergent series, an, bn, may be added or subtracted term by term. What it means is that if you have this series plus this series, that's just equivalent to a series of an plus bn. If the resulting series is convergent and its sum is obtained by adding or subtracting the sums of the two given series. The terms of an absolutely convergent series may be rearranged in any order without affecting either the convergence or the sum. However, we know from the previous slide that this is not true for conditionally convergent series.